So example number 4, determine the deflection at the free end. Okay, so first is, let's provide or name letters to every change of loading, A, B, C. And then we are going to solve for the resultant here. This is 1/2 of 25 times 2. This is 25. So we have the reaction here, RA and MA. Summation of moment about point A equal to 0. You will have negative MA plus 25 times 2/3 of 2 plus 1 equal to 0. So you will have transpose MA to the other side, it will become positive, and that's equal to 25 times, that's 4 over 3 plus 1, that's 7 over 3, and that is 25 times 7 over 3, 58.333. So that's 2/3 of 2 plus 1 times 25. Okay. Let's proceed. Let's solve for RA. Summation of forces vertical equal to 0. RA is just equal to 25 kilonewtons. And by the way, this is kilonewtons meter. And let's draw the moment by parts. This is for point A. This is for point B. And this is for point. Let's just copy this one. Copy, and this is for C. And then do not forget to write a horizontal 0 moment line. And then I will choose the rotation here because we have to decide para ani the maximum side of this triangular loading. So that's the reason nga nata diha. And then let's now create first degree line because of RA. So 25 times 3, you will have 75. So 25 times 3, that's 75. And then for this one, 25, it's first degree, mahimo siyang third degree. So kahimo niyang third degree, that's 25 times 1/3 of 2. So that's 16.667. So if that is the first degree line, mahimo na ni siyang third degree. And the value here is 16.667. And do not forget, for MA, rotation is clockwise. So how do you know kung positive na siya? I mean counterclockwise. How do you know kung positive ba na siya nga moment? So all we have to do is try to fix this point C, and then i-rotate na siya. The effect would be downward. So it's a negative moment. So therefore, we're going to plot that on the lower side. And the value here, so this is the illustration, and this is 58.333. This is at 0 degree line. Okay, so karon we're going to draw now the conjugate beam. Let's draw the conjugate beam. So I'll have here the beam. I'll just transfer it here. And by the way, naidaghang loading. So there. And then copy the loading. So I'll place the loading, this one, copy that, paste it here, and that. And of course, you write here, upward. So this is upward direction, and the value here is 75 with the first degree line. By the way, this is first degree. Seems like naay wala ko ganahi. Erase lang sa. And then this one, partial. There. Okay. Right. So, maghihapon, copy this load. So, I'll just copy that load and paste it here. And of course, you write a downward direction. Kay negative moment man ni siya. And we are going to copy the value. That's 16. Ano ang 1? That's 16.667. And also, do not forget, we are going to copy this portion. Copy that. Copy. And then paste it here. And then just delete this. And blue. This is erase. And then this is downward. Do not forget, downward na siya. And di lang ako siya So remember na atay duha ka loads diha. Okay. And then do not forget na siya yung mga reactions or resultants. I'll call this R1. And this is R2 for the spandrel, 3rd-degree line. And this is for R4. And let us evaluate the supports. So this is A prime now, this is B prime, this is C prime. And the supports, this one is a fix, so it will become a free end walay support. And then here, this is free end, it will now become a fixed support. There. So in this case, we now have a moment which I call MC prime and a vertical force which I'll call RC prime. So let's solve for the values of R1, R2, and R3. So R1, this is 1/2 of 75 times the total length is 3. So that's 0.5 of 75 and 3. So this is 112.5. And then R2 is base. The base is 2. The height is 16.667. N plus 1. So this is 3 plus 1. Okay. So that's 16.667 divided by 2. It's 8.334. Next, R3, it's going to be, R4? Anong R4 na siya? R3 lang. So, R3. So, R3, it is, I forgot, this is 58.833. Yes. So, this is 58.833 times 3. No, it's 58.333 only. So, sayop. This is 53.333. And this one, this is that. Okay, 58.333 times 3, it's 175. Okay, so this time we're now ready to solve for the free end deflection. Remember that MC prime in the conjugate beam is equal to this deflection at the real beam. So we need to solve for MC prime. So solving for MC prime, it's summation of moment about point C prime equal to 0, clockwise positive, counterclockwise negative. And since we have MC prime clockwise, so it's now positive MC prime. And then plus R1 times 1/3 of 3. Then minus R2 times, for a spandrel, it's going to be base of 2 divided by 2n, which is 3 plus 2. And then minus R3 times 1/2 of 3 equal to 0. So transposing MC prime to the other side, or all the terms rather, except MC prime to the other side, it will be negative R1. R1 of 112.5 and multiply it with 1. 1/3 of 3 is 1. And then plus R2, which is 8.334 times 2 over 5. And then plus R3, which is 175 times 1.5. Therefore, MC prime is 112.5 negative 112.5 times 1 plus 8.334 times 2 over 5 plus 175 times 1.5. the value is 153. So this is 153.334 kilonewtons cubic meter over EI. We arrive a value nga positive because our assumption nga clockwise is correct. So unsa may effect ana niya sa beam. So if that is clockwise with that beam, so this is our beam, for example, exaggerate lang nako ang length, and then this is MC prime. So ang tendency, so ato lang na siyang i-hold diha nga dapita. So ang mahitabo, it will bend downward. So in this bending downward, it is negative moment. So negative moment na siya. So it will create, no, ato na siyang ipa-plan dira. It will create a negative bending. Okay, therefore deflection at point C is equal to the same value, which is 153.334 kilonewtons cubic meter over EI, but we have to conform to that. That's negative moment, so it's downward deflection. And this is our answer for the free end deflection. So that's example number